So I have discussed different points and different important ideas of illuminations. Okay, so what I have discussed, so different important definitions of the illuminations, how they are related each other. Then I have discussed about some numerical problems based on your definitions. After that we discussed about the polar chart. Okay, polar chart means how the candle power is distributed throughout our, if depends upon the source. If it is point source, so how the candle power is distributed. Okay, if it is in fluorescent lamp, then how it will be distributed. Everything was discussed. Okay, what are the different types of source. Okay, so in last class I was discussed about different illumination, direct illumination, indirect illuminations. Okay, so how they are related each other. Okay, and what are the purpose of the illuminations. Okay, so different illumination systems. Okay, then end of the session I was discussed about the space and height ratio. Okay, so space and height ratio is important for our lighting purpose. Okay, so how much depth you have considered from your ceiling, from the ceiling to your lighting surface. Okay, so how much area is required to consideration, that is important. After that, the height of the lamps. Okay, so both are important for the illumination purpose, that I discussed in my last class. And which where we can observe that there is a means huge effect on the reflectors. Okay, the deflector design is the important features for the illumination. So today I am discussing about the different lighting schemes and the layout. Okay, basically today I have solved some numerical problems previous studies as well as today's study, and small numerical problem will be there, will be is discussed for your reference. At the time of examination, similar kinds of numerical problem will come. Okay, that will help you to solve the similar pattern of numerical problems in the time of exam. So pattern may be same, but problem may be different. Okay, so first we started with today's session with the design of lighting schemes and the layouts. Okay, so design of lighting schemes and layout means from the idea, so you can understand. So last class I discussed about different lighting schemes. Okay, and layout means how it will be, how the lights will be distributed. Means if you consider one big corridor in your institution, so how the lamp will be placed. Okay, how the lamp will be placed inside of the big corridor, and what will be the height of the lamp from the surface area. Means otherwise it will not be visible. Okay, so it totally depends the total calculations. Okay, so today our focused area is that how would you go for that lighting. Okay, in the practical cases. Okay, so first what are the important features for the design lighting scheme. Okay, first one is the provide adequate illuminations. Okay, so when you have installed one light, so if there is no adequate illuminations, means if the height is too if the height of the roof is too high and you have placed the lamp just top of the roof, then it is not possible to, then it is not possible to cover. Okay, it is not possible to cover the entire area. Okay, means good illuminating area. Okay, next one is the avoid the glare and hard shadows. So illumination will be like that, there should not be any hard shadows. Glare means any obstacles and the hard shadows, that should not be there. Okay, point number 3 is that the provide the sufficiency uniform distribution of light. So sufficiently uniform distribution of the light over all the working plane. Okay, so if there is not a sufficient light distribution, then what happens? Some of the portion will be dim, some of the portion will be bright. So there is an uneven light distribution that may cause for obstacles. Okay. and it may not gives you the better efficiency. Okay, so for getting the good for getting the optimum approach, so three things you need to be considered. Okay, so that adequate illuminations, hard avoid to use the hard shadows, and the uniform distribution of the light. Okay, so this effort, so another important few points are there. Okay, that is number, size, and proper arrangement of the lamps. Okay, three things are very important. Determine the number. Okay, how much numbers of lights are required. Then size. Okay, how it will be? Is it point source, or is it the fluorescent lamp or incandescent lamp? What will be the size on that source? Then proper arrangement of the lamps. Okay, to process the procedure given uniform illuminations. Okay, so illumination over the certain area. That's are the important points. Okay, so now another important features is that utilization factor. Okay, so utilization factor or the coefficient of utilization. So utilization factor is the very common term in the power system. Normally you know that utilization factor is more than 1. Okay, so try to more than 1. Okay, so it is related to the power plant utilization factors. Okay, so from that idea you can understand that utilization factor means in the reverse manner you say like that, it's an efficiency kind of thing, coefficient of the utilization, how efficient your system is it. Okay, so that may be expressed on numerical, that factor may be written in a ratio of the lumens actually received on the working plane whole divided by lumens emitted by the light source. Means how much lumens you can getting, okay, in the working plane, and what is your emitted light source, like your efficiency. Okay, means how much power, output power to the input power. Okay, input power will be what, output power plus losses. Same kinds of thing also happened here. Okay, how much lumens you have received at a working plane. Okay, some of the lights, few of the beams maybe few of the beams may be lost. Okay, maybe lost due to the environmental conditions, and divided by lumens emitted and the light source, means how much input is there. Okay, so that is coming the ratio. Okay, so it is the ratio, that's a written, it is the ratio of the lumens actually received by the particular surface to the total lumens emitted by the luminous surface, means luminous source. Okay, so simple thing, the value of this factor. So as it is neta is there. Okay, so as the value of factors is there, so definitely it will vary with the different points, important features. Okay, widely varying widely, and depends on the following factors. What are the important factors? Number one is that the type of the lighting system, whether direct or indirect. Last class I discussed about different lighting system, that efficiency depends upon the lighting system. Second one is that the type and the mounting height of the fittings. Okay, so how much height, today just I started with that, how much length from the roof. Okay, if it is mounting, means it is hanging from the roof, okay, ceiling of your room. Okay, so how much height of that hanging wire. Okay, so that is important. Next one will be the how much length. Okay, means if it is in, like in your garden lighting. Okay, in case of garden lighting, what happen, it is not, it is also mounted, but there is some permanent structure behind of that light, and it will be installed surface of the garden. Okay, so how much height is there? So that's why it is written the type and the mounting height of the fittings. Fittings means lighting and the accessories, means it may be point source, it may be fluorescent type, means surface source, whatever sources are there. So directly it will be associated with the reflectors. Okay, another diffusing materials. Okay, a lot of casings also be there. That entire thing is known as fittings. Okay, number 3 point is the color and the surface of wall and the ceiling. So how it will be, what is the color? Okay, so if it is red color, so what will be the, if the surface color is red or the bulb color is red, so it will be different. If it is yellow, definitely it will be different. So white is more acceptable. Basically in white color means it's a combination, so it's the combinations of all the colors. Okay, so white means the room looks like brighter. Okay, if other color means it may cause for dimmer. Okay, means blue, red means it can absorb red color and so absorb the other color and I think reflect the red color. Okay, so that's the point. Okay, the color and the surface wall of the ceiling. Then next point is that some extent on the shape and dimensions of the room. Okay, if your dimension of the room is, if the rooms look like a hall, okay, means hall type of rooms, big room is there and you are just hanging or mounting only one lamp inside of that room, so it is sufficient enough to accommodate that light is sufficient enough to accommodate the throughout the room, not possible. Okay, so that's why the optimum sizing or optimum number of lights is required. So how much number of lights are required, that you need to calculate. Okay, so here you can understand 4 points are there. Okay, for that utilization factor or the coefficient of the illuminations. Okay, so then some examples also be there. Okay, for understanding the theta value varies. Okay, how that values are varies practically with some examples. Okay, for direct lighting. Okay, in our first case we are considering the direct lighting. The theta value is varies between 0.4 to zero point 0.6. Direct lighting means what? There is no, or reflected is there, just it will be reflecting all the light throughout your surface area, means your surface will be illuminated. Okay, so how is it possible? So direct light is coming from the source. Okay, and it will be reflected from the source, so it's a direct lighting. And that theta varies between the zero point 0.6 zero point 4 to zero point 0.6. Okay, mainly depends on the shape of the room. Okay, so directly light will be coming to the workplace or the workspace. Okay, or the work surface. Okay, so shape of the room, basically the room is small inside, so directly that light is accommodated throughout the room. If it is a big room, so it is not possible to accommodate number. So shape of the room and the type and the mounting height of the fittings. Okay, so what type of light is there? Okay, the mounting height of the fittings, but very little on the color of the wall and the ceiling. Basically all the light is coming to your workspace. Okay, so then definitely it will depends the color of the room. Okay, so still the most of the thrust is going on what type of light is there, how the height will be considered, that kinds of points you are following. Okay, this is for direct lighting. For indirect lighting, what happened? In indirect lighting, the value between the theta value between the 0.1 to 0.35, so efficiency is less. So 0.4 to 6 means 0.6 means more or less 40% to 60%. Okay, but 0.1 to 0.35 means 10% to 35% for indirect lighting. Okay, so the effects of the walls, definitely basically it is diffusion. So indirect lighting means directly light will not come to your system, so it will be diffused. Basically backside light will emitted from the backside and it will be reflected from the ceiling and coming back to your workspace. So that's why most of the light will be not lost. Actually lost is not the exact terminology, so you will not get that value. Okay, and the effect of the walls and the ceiling. Okay, that you can find out here. Okay, and the light is reflected on the working plane. Okay, so light is coming back here is much greater. Okay, so how much value? So totally depends upon a reflected one. Okay, so exact determinations of the value of utilization factor is complicated, especially in the small room. Okay, especially for the small room it is complicated where the light undergoes multiple reflections. Okay, means in case of what happens, a lot of concentrator will be there, reflector will be there, that also been focused on propagate to, that means motivated to provide the good lighting effort to the system. So that's why it is quite difficult to measure for the in the small room. Overall it is simple to understand. So generalized values are given, that is 0.6 to 0.4 to 0.6 for the direct lighting, and for indirect lighting it is 0.1 to 0.35. Since the light leaving the lamp is different directions, okay, the different direction is subject to the different degrees. Okay, So definitely that reflections definitely means some angle will be there. Okay, so with different angle of the positioning, different angle positioning of the reflector may cause for different degree of the reflections. Okay, of the absorption, and another in case of indirect, so absorption will be there, and the initial polar curve of the distribution has to be taken into the account. Even through the manufacturers of the lighting fitting supply tables giving the utilization factor, okay, of the each of the fitting under the specific conditions yet. Okay, since such tables applied only the fittings for which they have been compiled, a good deal of the judgment is necessary while using them. So normally, I think all of you are aware about the data sheet of the components. Okay, means when we are purchasing any of the lighting substance, any of the lights, any of the means fitting, especially the fittings from any of the companies, normally we should download the data sheet. So company will tested it, that manufacturing company first they have tested it, okay, and they have prepared the data sheet, and you have to download the data sheet first from the internet. Okay, so if you have the data sheet, so in case of data sheet everything is given. Okay, how much angle is there, what is your neta value, means utilization factor, they have tested it in their company, okay, in their lab, and they have provided and prepared the data sheet. Okay, so then they goes for the bulk productions. Okay, it doesn't mean that each and every bulb will be tested. So they are going for the bulk production. Then any fault has occurred, so definitely that will be returned back to the company, means manufacturing company, and it will be exchanged at the point of the shop. Okay, and the customers. Okay, but normally for single lamp they have tested. Okay, then they go for the bulk productions, means batch productions. Okay, so it is not possible for individually they have testing, then they gives you the idea. It's not like that. Okay, so they are tested first for the one lamp and give the prepare that data sheet, and that data sheet is available to the net, and whatever purpose you have, so you just download the data sheet and cross check it. Okay, is it fulfilling your concept, fulfilling your idea? So if it is fulfilling, so there will be no problem, directly you can take it. If it is not fulfilling your idea, so you should think about the another type of material. Okay, that's the motivations. Okay, next one is the depreciation factor. Okay, that is P. Okay, so last one was your utilization factor, now depreciation factor. Again you can say it's an ratio. Okay, ratio between the illuminations under the actual conditions to the illuminations when the everything is perfectly clean. Means you know that last class I discussed there is a moisture, there is some problem on that moisture, okay, or the dusty area that may affects of your efficiency of the illuminating plane or illuminating source. Okay, means if the dust is more in the reflector, then what happen in industry, means somehow is industrial application you are using that lamp for direct lighting, you are using some lamp. Okay, so in industry what happened, lot of dusters there, maybe fly ash dust, coal dust, everything is there, so that may give you one unwanted coating on unwanted coating across reflectors. Okay, then what happened, that some of the light will be absorbed by that dust particles. Okay, so that efficiency will be less. Okay, that's why that depreciation factor. The depreciations means how much depreciation is occur. So depreciation of asset. Depreciation is the terminology related to the management. Okay, management studies. Okay, so how much the depreciation is observed. Depreciation of the assets. Okay, normally you know that common terminology, depreciations of the assets. Okay, so that you need to calculate. So illuminations under the actual conditions, how much illuminations you are obtaining from there, and if there is no loss, means there is no dust and perfectly clean, how much value will be there. Okay, so that value you have to calculate. Okay, so the factors, that's why it is written, the factors allow for the facts and the effective candle power. Okay, fact and that effective candle power for all the lamps. Okay, or the luminous source deteriorates owing of the blackening and the accumulations of the dust or the dirt on the globes okay, that I am telling you, and the reflector, etc. Okay, similarly, wall and ceiling, etc. So dust may cause for unwanted diffusions, unwanted absorptions of the light. Okay, so that may cause for unwanted edging effects of the light source. Okay, so also do not reflect as much light as when they are clean. So you have to think about the when calculation, so when it will be clean, the value of this factor may be taken as 1 by 1.3 if the lamps fitting are likely to be cleaned regularly, or 1.15 if there is much dust there. Okay, so that value will be 1.15, 1 by 1.15 when it will be cleaned properly. Okay, means 10 by 13. Okay, so 10 by 13, if it is 10 by 15, if it is not clean, means denominator is more. 10 by 13 means denominator is less, denominator is 13, and 10 by 15, 1 by 1.5 means 10 by 1.5, 10 by 15. So 15 means denominator is more than your previous one. So you will get the less P value. Okay, that's why depreciation factor is there. Okay, then another point is there. So since the illumination is specified in lumen per meter square, okay, lumen per meter square, the area in square meter multiplied by the illumination required in lumen per meter square gives the total useful luminous flux that must reach the working plane. Okay, taking into the consideration of the utilizations and the depreciation or the maintenance factor, the expressions of the gross lumens is, you will get the expression. So that is your flux, means how much flux you have obtained. E into A whole divided by neta into P. Okay, E means you know that desired illumination lumen per meter square. You know that one. A is the area, simple thing, luminous per meter square. Then P is the depreciation or the maintenance factor. Okay, and N is the utilization factor. So directly you will get the number of flux line. Flux line is light flux. Okay, so that's the equation. Simple thing. The size of the lumen, okay, sorry, the size of the lamp, okay, depends on the number of fittings, okay, which if the uniform distribution is required. Okay, number of fittings, that how much uniform distribution you are asking for it. Okay, and for the far apart, the actual spacing and arrangement is governed by space per height values and by the layout of the ceiling beam of the or the columns. Okay, so you have to design the ceiling beam and the columns, how much values are there. Okay, greater height means greater height with the spacing may be used for, also the larger will be the unit required. So larger unit required. Okay, if the values is more, so larger amount will be required. Having settled the number of the unit required, the lumens per unit may be found from the total lumens per number of unit. Okay, from which the size of the lamp can be calculated. By this way you can calculate the lamp sizing. Okay, I think all of you are able to understand what is the utilization factor, what is the depreciation factor, what is illumination flux. Okay, everything you can understand from the formulas. Okay, so that I have been discussed here. Now we are solving some small numerical problem based on that formulas. Okay, so first example, you can see example 1, you can see that a room of 8 meter into 8 meter plus 12 meter, sorry, 8 meter cross 12 meter is lighted by the 15 ampere, 15 lamps. Okay, 15 lamps are there to fairly uniform illuminations. Okay, illumination is uniform. Okay, that values are there, 100 lumens per meter square. Okay, so now what you need to calculate the utilization coefficient, okay, or utilization factor, okay, of the room given of the outputs of the each lamp is 1600 lumens. So simple thing. So lumens emitted by the lamp is 15 into 1600. So 15 lamps are there. So that is 24,000 lumen. Lumen received by the working plane. All of you please solve it to a class or copy. Okay, that is important. That type of question will come at the time of exam. Simple question, but simple thing, but you have to solve it. Okay, in the time of examination. Okay, So that's why I'm telling you, solve it to your classwork copy. When you are submitting your classwork copy, that should be there. All the numerical problems should be there in your classwork copy. Okay. So here you can see, so lumen received by the working plane of the room is, that area is given 8 into 12 and 100 lumen per meter square is given, that uniformly fared. So it is 9600 lumens is coming. Okay, so 100 lumen per meter square, that is 8 into 12, unit is meter square. So meter square, both are cancel each other, so it is coming 9600 lumen. Okay, the utilization coefficient means area, that you know that value, utilization coefficient, lumen actually received at the work plane and lumen emitted by the light source. How much lumen emitted by the light source? That is 24,000. Okay, and received, how value you have received, that is 9600 lumen. So both a ratio you can find out, that is 0.4 means 40%. Okay, that is correct. So next example, all of you try to solve. The illuminations in a drawing office, area is given 30 meter into 10 meter, have the value of 250 lakhs. Okay, and to be provided by the number of 300-watt filament lamps. Okay, 300-watt filament lamps. If the coefficient of utilization is given zero point 0.4, okay, so that neta value is given. Okay, and the depreciation factor, okay, that P also be there. Okay, determine the number of lamps required and luminous efficiency of the lamp is 14 lumen per watt. So you have to find out the flux, luminous flux you have to calculate. So EA equal to EA whole divided by N into P. So you know the value of N equal to given, but P is there 90%, mean depreciation factor is 0.9, P is there. Okay, neta value utilization factor also be there 0.4, it is 0.4 is given. Okay, now area you have to calculate, area is also given 30 into 10, 300 meters square. So E value equal to what? 250 lakhs. E equal to there, illumination value is there. E is what? Is the desired illuminations in lumen per meter square, means lakhs. Okay, that 250 is given, E equal to 250 lakhs is given. Okay, now you replace all those things, 250 into 300 whole divided by that value, so flux you can find out 280, 208,333. So just cross check that value, is it coming right or wrong? Cross check that one. Okay, then what you need to do, then flux emitted, so flux emitted per lamp, so per lamp it is given 14 lumen per watt. Okay, so total emission is 208 208,633 lumen. So now that 300 that area is 300, one lamp is responsible to flow that 14 lumen per watt. Okay, so now it is 300 into 14 means it 4200 lumen. Okay, so number of lamp is there, so total this value divided by 4200, so nearer it is coming 50. Accurate value considered, this is approximated number of lamp is not possible practically. So that's why round figure value should be taken to nearer, it should be calculated nearer to the value. Okay. Now you can go for the calculations. So another problem example. Okay, so find out, you have to calculate the find the total saving, okay, of in electrical load and percentage of increase of illuminations instead of the using the 12 150 watt tungsten filament lamp, we use 1280 watt fluorescent tubes. Okay, maybe assume that number one, there is a choke loss is 25% of the rated lamp wattage. Okay, then average luminous efficiency throughout the life for each lamp is 15 lumen per watt, and for each tube 40 lumen per watt, and the coefficient of utilization remains the same in the both case. Okay, that you have to calculate. So solution, from solution what you can calculate, the total load of fluorescent lamp is 12 into 150, that is 1800 watt. Okay, so total lamp is coming, so 12 into 150, 1800 watt. Then total load of tube is 12 into 80 plus 0.25 into 80. Okay, so from there you are getting, so that value is already there, 25% it is mentioned, and number of efficient 80 watt fluorescent tubes are there. So how much energy wattage calculation is there. Okay, that's why you have to finding out that process. Okay, 12 into 80 plus 12 into 0.25 into 80, so finally it is coming 1200 watt. So net saving of the load is 1800 minus 1200, so it is 6600 watt it is saving. Now you have to find out the, the area. Okay, you have to calculate the area and neta efficiency, then you have to know, so what is the value of E1. Okay, so you can get that value from the flux line, you can easily get that one. So U1 equal to 12 into 15, 115 to 15 neta into divided by A. So you can replace that value and finally you will get that one. Then illumination with the tubes, that is illumination for the lamp. Then you are calculating illumination for the tube, that is E2. Okay, then again you can find out that value. Now increase of the illumination means 38400 n by a minus 27000 n by a whole divided by 27,000 n by a neta by a. So finally it is coming 42%. I think you are getting that points. So simple problem, but you have to think in that manner. Okay. So another two problems are there. Okay, you can solve. Okay, you can solve it to your house. Okay, that portion I will share. Okay, so you can take idea from that problems and you can solve it to your home or hostel for your benefit. Okay, so what are the next problem? Next problem is that a drawing hall. Okay, that one drawing hall is there, and engineering college is there, drawing hall engineering college. So provided the lighting installation, hall size is there, 30 meter into 20 meter and 8 meter height is there. Okay, the mounting height of the lamp is 5 meter, the required is level of illumination is 144 lumen per meter square. Using the metal filament lamps are there, estimate the size and number height